update myself. Okay, so thank you for joining me. As I said, this is going to be a kind of a invitation only, very small attendance webinar because, frankly, because I'm a little scared. I wondered about what would happen if you discovered atomic power, if you could build fusion in your refrigerator or something, and you knew that it would change the world. You weren't sure exactly how, and you weren't sure who to tell. Like Tesla's inventions. They say that they tested an electric car, and Tesla brought a little box, and the car ran for several days on this little box. I mean, somebody else built the car. He brought the power supply. And people have puzzled about that ever since. What did he do? Okay, well, we've got such a catastrophe going on in AI. This morning I talked about, 10 biggest AI fails in 2017, 2018, 2019. The literature's full of information. I mean, we know that Watson beat the Jeopardy players. We know that. So we know that it can do some things. But whenever we kind of let it go on its own, it's a disaster. So let's get started and talk about actual case studies, actual results, and why and how it all works together. I'm going to hit the down key. Now, first, I wanted to say that this is not my first rodeo. We started with the Hudson Bay, which I noticed the other day. They announced Friday that it was going private again, which I think is a great move. That was our first big data project where we loaded 250 million transactions on the first Intel Pentium coming off the line from NCR. It was one of the first 5. And they particularly wanted to give it to us because the Hudson Bay Company was on twin ES9000, biggest mainframes they had, and we claimed we could, on a PC, build something of value. We ended up on the Borland website. Intel flew out to see us. We did work for IBM and Microsoft and Adobe. So we were before the cloud. We were before the big data move. But anyway, shortly thereafter, the first real client we had that was going to put something in the mail, we should have put something in the mail with Hudson Bay. We were working with National Credit, and we could have done the inserters. We could have driven them. But, I was kind of self-taught in this stuff. And Connie Bauer, Professor Connie Bauer from Marquette, did get me started. And after about 6 weeks, I still hadn't seen a model. Hudson Bay said, we want a model for our best customers. And so Connie said you could build a good model with 50 customers as long as they were the right customers. I said, but Connie, we got 14 million here in our database. And we got hundreds of thousands of transactions. And so I kind of took the manual home and started on my own. And the next day I built my first model. And we didn't know what we were doing. And I mean a minute. But this was 1994. And so then then Cabela's decided to hire us, and they were doing RFM, and it's in my book. And they told me on the first fishing model, working with Dick Cabela, who said, yep, this is what fishermen are like. We put it in the mail. They said that they made $2.4 million in additional profit because of our model. Now, they were mailing 5 million pieces, so it was a good deal. Dick sent me my first bow and arrow, and the first day out, I got my first deer with it. You won't get stories like this from your average statistician, I can tell you that. We then, along the way, actually, we had landed Adobe, and a friend of mine was running Baseball Express, Rich Covio. And he said, could you do something for us? And I said, I don't know. You're a little bit small. I think they were mailing 100,000 pieces or something on an average drop. Anyway, but when you're loading 10 million names and millions and millions of transactions, there's the computer's running and chugging, and there's only so much you can do. So, unknown to me, my team loaded up Baseball Express, and I got a call. I said, you can play with this one if you want, but don't cut into Adobe, because they were paying us about $90,000 a month. And so, unknown to me, they built a model and put it in the mail. And I get a call from Rich, and he says, "Hey, what did you do?" I said, "What do you mean?" "Oh, yeah, what?" And he said, "We've never seen response rates like this. The top cells that you pulled did triple our best response ever." And, I have to be honest. When I was doing the Cabela's, I didn't have much faith in our modeling system, partly because, I called Tim Mabey, who is a PhD statistician at Neiman Marcus, and I said, "Tim, we don't see recency in our modeling." And Tim said, "Well, if recency isn't at the top, then you probably did something wrong." Well, we couldn't figure out what we'd done wrong until I realized that if you're pulling fishing names in December, and you're looking at the most recent names, you're going to get hunters, which is why they didn't respond. And again, that's in my book. But and this is why you have to have some common sense. You have to have some awareness of the world. You have to have some life experience to make this stuff work. And if you don't, it's very, very dangerous. Which again is my point. So anyway, Baseball Express kept us around for 10 years with like 5 different ownership changes. And we took them from 5 million in sales to 50 million. And, really a lot of fun. And then Adobe along the way, we took from 25 million annualized to 50 million in about 6 months. We also found 40,000 names they were mailing over and over and over that were dead. So that saved them a good $20,000 a month, or something like that right off the bat, 20, 30 grand. Musician's Friend was an interesting story. They kept us for 6 years, again with many regime changes. And they kept trying to test against us because I think they didn't believe, Guitar Center didn't believe this stuff worked. And so I got a call one day from Travis Seaton at Cohere One. Travis, a great guy, If you're going to work with Cohere One, try to work with Travis. He's got good common sense, got some great case studies. Anyway, Travis calls up. He said, "Did you know you've been accused of cheating?" I said, "Cheating what?" "Cheating on what?" And he said, "Well, they teamed up with the Guitar Center people, teamed up with the faculty at UCLA in the statistics department, and they did a uniques test, and you won by 321%. And they said, that's impossible. No one could win by that. It's impossible. You must have cheated." I said, "I didn't know they were testing." He said, "Yeah, they've been testing all along. They have like 11 tests against 8 different modeling companies, and Cognitive Data and all the big names around the world. They were testing me against, and the average win was 60%. So, we've been in these tests before, and that's why I want to go into this a little bit. And then Lovesac, just a great case study. If you're in e-commerce and retail, which is kind of where their space was, they were more like retail with a heavy emphasis on e-commerce and then an afterthought of mail. We were able to leverage the mail into explosive growth from 2014 through 2017, 100% growth in 3 years in retail, and those weren't the best retail years. So, and they hadn't been growing like that. They've been around for 15 years. Now they're public, and I understand they're growing still, which is great. They took what we did and they morphed it into something else, which is fine. But I'll share some of that. It's all public, because they're a public company now. So, nothing super confidential here, but I just want you to know that this is not an anomaly. This is a continuation of exploration and discovery for 25 years. Okay? So, what are we going to cover today? We're going to cover AI history, why 87% of data science projects fail, why CEOs want ROI, why data science is tricky, and how our process differs. Plus, we're going to give you the results that we got on Christmas Eve. First, an AI definition. This is from the head of machine learning at Intel. And, Matthew Shaw, PhD statistician, said, why are you even talking about AI? You're not really AI. You're more machine learning. They're connected. It's a lot shorter. Works better in a headline. AI ROI. And so this guy from Intel says, AI is the science and machine learning is the algorithms that make the machines smarter. So the enabler for AI is machine learning. And what that really says is that the engine, you've got your aeronautical engineers, scoping out the drag of the car, but somebody's going to have to put it together. Well, the fact is, I think that there's not enough people really doing the machine learning and putting it together properly. But I'll tell you something else that happens along the way. When you get the car going, from 30 to 60, it changes the airflow. And from 60 to 120 changes the airflow. And I was watching this great stuff on the Lotus, the new Lotus that's coming out with the suction down to the road, and theoretically, I heard this from someone at Lotus. They're able to take a track and they've turned it upside down. They call it the, what do they call it? The ceiling pig or something. It's from The Simpsons. That this car, I don't know if it's actually done it, or I couldn't find a video, but they said that they think that it can go on a quarter-mile track upside down because it's got that much downforce that it will keep it on the ground. So when you get your engineers going fast enough and light enough and all of it comes together, it changes the AI. That's my big point. My big point is machine learning might be the engine and might be the engineering part, but it's what makes it work. It's what makes it pay off. So we'll talk about AI because it's the more generic. And this is a eye chart. We're not going to talk about it too much, but I was shocked that in 1912 there was a mechanical chess demonstration at the Chicago World's Fair. In 1943, McCullough and Pitts theorized neural net computing. Goes back quite a ways. Alan Turing came up with his test in 1950. The term artificial intelligence was coined in 1956. It's about my age. And MIT did their first chatbot in 1964. We used to play Zork in 1984. A guy at Mercedes created a van that would go 39 miles an hour on deserted streets. Deep Blue defeated Garry Kasparov in 1989. 2011, Watson wins Jeopardy. But as we pointed out this morning on the live stream, I invite you, if you're on Periscope, to look up John Miglosh and follow, and because we do this every day, and you'll get a lot of head shaking information. And then in 2017, AlphaGo defeats the World Go champion. So we're told it's going to any minute now it's going to take over. So if that's true, why, according to Gartner, do 87% of data science projects fail? Right. Well, when that first came out, I think it was 85, 2-3 years ago, they said 85% of AI projects don't ever get to ROI. They said it was because as the project fails to complete implementation, the price goes up and therefore the risk goes up and the focus on the goal gets confused. That's what they said. What do I say? Well, first of all, what the CEO wants is they want AI return on investment. That's all CEOs. I mean, all chief officers want growth and profit. That's what the shareholders hold them accountable to. And they believe that AI can give them insights into things like customer values, customer journey, maybe the next customer that's going to buy. They want scalable growth. There are precious few tools to really give you insight into the future, and they suspect that AI might do that. When we look at, if you read article after article, and obviously I read dozens and dozens of articles. I have them on my phone, so when I drive, I can have getpocket.com read them to me, which is quite an interesting app. What you see is that about half of the top 10 goals for machine learning, if you Google that, are related to marketing, related to customers, improving understanding of customers, retaining customers, cross-selling to customers, and acquiring customers. It's like that's the heart of marketing, right? So what we're hoping for is AI to give us help with all the data we piled up and make some sense of it. And the challenge is that what you need, and this is a part that people don't get, you need, for machine learning, you need a labeled data set. When Watson won Jeopardy, they had 120,000 clues. 120,000 Jeopardy question answer sets. And so what they could do is they could play with it. They could build algorithms that said, okay, look for the nouns. They take a grammar checker and say, where are the nouns in this answer? Jeopardy technically is giving you an answer and asking you what the question is. Where are the nouns? And let's say it's Michigan, Superior, Erie. And so Watson might say, oh, what if you Googled that? If you Googled just Michigan, Superior, and Erie, you'd probably get what are the Great Lakes, or what are the biggest Great Lakes, or something. And that would make sense. Now the problem is that then you got to look for negations. There's a lot of complexity. You might have to look for verbs. And so what you do is you'd start that process, run it against the 120,000, and you could keep track against right and wrong. Did the machine get it right? Did the machine get it wrong? And you could look at it with a human if you wanted. You take sample sets and look at it with a human and say, well, this is close or this isn't close. And basically what Watson did was build probabilities of likely questions that would find the commonality. Okay, so it worked fine. Now, famous second step, they took it down to the University of Texas, and IBM said, well, for $3 million, we'll have this thing diagnosing cancer from X-rays and MRI scans. So they said, oh, great, $3 million, yeah, that's, it costs that just to install an MRI. This would be great. Well, after $63 million and several years of trying, the doctor said, there's too many false positives. It's too unreliable. And so they shut it down and sued IBM. And an article I talked about this morning said Watson still hasn't really been applied to any other world besides Jeopardy. And it's not something you can hold in your hand either. It was 90 servers. It couldn't access the internet, though searching Google gives you a feel for this. But too, that about 90% of the stuff that Google comes back with is not what you're looking for, right? Now, the other thing I was telling people, and this is kind of a surprise to people, I was logging into Twitter on a machine that I don't usually log in on, and 5 of these things came up. It said, are you human? Check the box. And then it said, select all the squares of traffic lights. So bump, 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 right? And 5 sets of those pictures came up. I was shocked. Now, I asked friends, what do you think that's about? Why are they all about traffic lights and traffic signs and where's the crosswalk? And they said, well, they want to know if we're human. I said, no, that's not what they want at all. What they want is they want a labeled data set. They want enough pictures that have been looked at and defined by a human. So a human can say, oh yeah, here they are, bing, 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 bing. One of the problems that computers have is like these are backwards. These are aim in the other direction. And there aren't any on this side of the street that are aiming the proper direction. So it's like, okay, these are backwards. These don't look like stoplights. This one has a green light or has a yellow light or whatever. This down here looks like what we think of as a stoplight. This looks like a black box in the middle of a picture. But a human doesn't have any trouble saying, oh, that's a stoplight. Computer will have a lot of trouble with that, with partial pictures and partial shapes. And that was on today's program this morning. That the ambiguity and the context are terrible for computers, and that's their real failure. Okay? So what they're doing to you is they're using you to generate images that can be used to train the self-driving cars so that they can recognize a stop sign, recognize a traffic light, even if it's damaged, even if it's been sprayed with graffiti. Because what they found was that you can take a car and drive it to work, self-driving, and it'll see a stoplight or a stop sign, come to a stop, come to a stop. You can do it 100 times in a row. You take a little sticker, put a sticker on it, and it won't realize that that's a stop sign. Even though it's a 90% same stop sign, that sticker can interrupt it and say, well, that could be a stop sign, but it's only 70% chance, and I don't stop for 70% chances. Right through, kill somebody. See how interesting this is? I hope you're thinking it's interesting. Okay, there's also some challenges in marketing when everybody's going all in. This is from 2017. This is from 2017. That's a new movie that's out in my head. Okay, 350 top marketing companies. 45% say they're unable to show the impact of social media. 40% have a qualitative but not quantitative sense for the impact of social media. That means they feel like it ought to work, but it doesn't. Procter & Gamble slashed its digital ad spend 40%, and sales did not go down. Sales went up. Sales went up. Okay? This is a case study for you. Now, I'm going to talk for a minute about mail. I am a huge fan of mail, but it's more important than that, because I got to thinking, okay, if all these AI projects fail, and yet I've been successful at machine learning for 25 years, beating RFM, beating other modelers, what are the differentiating factors that we have? One is mail. We use a lot. We basically only do mail. We could do email. We could do digital. But, people say, well, this mail is expensive. We've got to figure that out. And then we apply it to other areas. And that's what one of the case studies we're going to talk about. Okay? But mail has some differentiating features. One is that your brain has 10 times more touch than vision processing. It's something more real. When Wayfair sends you a postcard, it's got sound, it's got shiny feel, it's got smell, especially when it first comes, and here's another one, I think, by Wayfair. Yeah, Wayfair, and this one's a fold-out. It's a multi-page. It's kind of glued up. See, Wayfair. It gives you something that your brain gets around, and a catalog even more so. It's sort of a halfway point between mass media and retail, or being actually in the store. So there's a reality level in your brain that's way higher for touch than for vision, or vision alone, we could say. So mail, and this is key, and I want you to burn this in, mail gives you a foundation for machine learning. What do I mean? Well, first of all, it connects with your brain. And I have slide after slide after slide. I really took this down to nothing. But it connects with your brain at a tenfold increase over a banner ad on your screen, right? Or a TV commercial even. Okay? Tenfold level magnitude. Okay? Which means, this is what the meaning is, it means that there's a guaranteed engagement. You say, oh, I throw all that stuff in the mail, in the trash. Yeah, I know, but some other things come in the mail, like bills, like bank statements, like insurance notices. The important stuff still comes in the mail, which means you got to look at it. You got to sort the wheat from the chaff, right? And what that means is that you have to pick it up and look at it. You don't just take your mail from the mailbox and just throw it all away. You look, throw, look, save. Okay, which means we have a guaranteed engagement. You might think that since digital is 1/5, or rather 1/20th the cost of mail, that perhaps if you do 20 banner ads for every one piece of mail, you'll get the same benefit. It doesn't quite work that way, because we're actually training ourselves to ignore the periphery of the website. And of course we get up and get a sandwich when the TV commercial runs. Right? Now I'm not saying it's totally inadequate, because I can tell you about Cross Your Heart bras and nothing I'd walk a mile for a camel, that from when I was a kid. Still, I don't care anything about either of those two products, but I know their slogans because lift and separate, because it pounded enough, right? So I'm not saying there isn't engagement with regular advertising, but I'm saying that the tricky part is we don't know for sure. We don't know for sure if people saw it or didn't see it. Now, here's where the rubber meets the road. When we mail, we ship it to your house, okay? So we mail it to your house and we ship it to your house, which means we know who got mailed, we know there's an engagement, and we know who bought. And we can match back who bought to the who got mailed, okay? Which means that we can run tests at a different level, because with machine learning applied to banner ads or even email, sure, you can check open rates and things, but it's not always clear that the same email you sent to was the one used to purchase. Very, very often it's not, right? There's all kinds of slippage in there. Whereas with mail, we know who got mailed with certainty. We know they looked with certainty, and we know which ones bought and which ones didn't. And that is like the human labeling the images for the self-driving cars. It delivers a labeled data set. And this is powerful, because what I'm saying to you is, if you're not using mail, you may never get AI to work. And I know it's radical, it's crazy. It's crazy to say, gee, the reason 87% of the marketing AI projects fail is because they don't have a good labeled data set. They should be using mail. USPS ought to rebroadcast this. You want AI to work? Let's do mail. And people laugh at me when I say this. Although, people got laughed at when they said, the internet's going to be big. I remember when you'd get flamed if you tried to sell something on the internet. There was debate on the internet whether it would ever have commercial application. Yes, sir. I remember that. I built my first website in 1995. So I know. I was there. And I was a SciSop in the 80s, where we had bulletin boards on marketing. And when I go to a conference, people would get on and we would exchange messages and we could chat even real time in the 80s. Okay? So I know you think that you invented it all, but it ain't so. It's been around a while, and there's a reason why AI fails. One of the big reasons is people don't know why they bought. People can't articulate it in their own minds. If you ask them, they'll give you wrong answers. They're very easily persuaded about why they bought, and they don't remember. So if you want hard data, you need high engagement and you need something rock solid, which is the ship to address. Mail to address, ship to address. We can compare it. Okay, so there are 5 steps in machine learning. Mail is the best labeled data set. It has high engagement. It has the best attribution and tracking because we mail to the house and we ship to the house. Let's talk about case studies. May of this year, Eric Nordstrom got on the shareholder call and said, our results were hurt by stopping the use of direct mail. And about the same time, Jill, Linda Heasley, President and CEO, said we planned some shift from direct mail to alternative media options, primarily digital. In hindsight, we moved too much too soon. And Linda, after her $6 million deal, mostly in Jill's stock, which she damaged, is gone. What a deal, And she did some other good things for other companies, but her big shtick was, oh yeah, we don't need all these catalogs. And if you go on Jill's website, you can't even hardly ask for a catalog anymore. I mean, they've just gone all in, and I don't expect them to survive unless they change. But so what I'm illustrating here is a mailer that's decided it's not chic to do mail. You're going the wrong direction. There's a lot of mailers who stopped mailing who are gone today. And there's a lot of people who keep mailing who are still here. Again. Okay, so here's a case study. We worked with Lovesac from summer of 14 through summer of 17. 4 years, kind of. And in year 1, we started working on circulation. We had a new vice president of marketing, and he said, why would we mail to people that already know what we do? The problem we have is not enough people have heard of us. We should be out getting name recognition. I said, that's a really, really smart perspective. We can test that because some other consultant had told them they should have a catalog. I said, we can test that. He said, really? I said, yeah. And he came from a packaged goods company and he had no mail experience. I said, what we'll do is we'll take several thousand customers and not mail them on purpose. And we'll do it very carefully, because you get a ranking. When you do a mailing, you get a ranking of best to worst that you want, and then below which you don't want to mail. We'll take what they call as nth, like fifths or tenths. We'll take a tenth out of each of those cells so we know that we're getting a good panel, which is better actually than just a random selection, because a random selection will tend to, because of the 80-20 rule, will tend to grab the poorer names. So instead, we overlay best to worst and take a random of each one. It's a little like the Electoral College, where you can say that the popular vote went a certain way, but you can also say the winner is the one who wins the 48-50, the 50 contests. Individual contests. It's really irrelevant. And you can say you like it or you can say you don't like it. The problem is that as the founders realized, the biggest states are going to make the whole decision, and the candidates will never have to go visit the little states. So now we talk about Wisconsin being a big impact, and Trump came, I don't know how many times, 4 or 5 anyway, and Hillary didn't come at all. She spent her time in California and New York, which she had already bagged. And that was just poor execution. You can blame the Russians if you want. But anyway, so we did the same thing. We did individual samples throughout the model. And we compared the sales of people who hadn't been mailed with people who had. And I have a couple of graphs from Musician's Friend and stuff. But basically, we got a 300% ROI. Year 2, which said that mailing the existing customers boosted their sales by by the overall cost of the mailing times 3 and profit. 300% profit per piece compared to the cost of the mailing. So it was a pretty good deal. And so Patrick said, okay, let's keep going. Year 2, we did, there was this theory that we didn't have to open any new stores if we put a lot of investment into the website. Sound familiar? If we have investment in the website, then customers can be anywhere. And I'm not, you can't obviously see any detail here. In the real maps, we could drill in and find it. But the gist of it was that in a ridiculous way, the web customers were near the stores. And so this idea that you could somehow service Mississippi where you have no, or Arkansas where you have no stores at all, or Montana. Now the irony was, people, we had a lot of customers in North Dakota. We were, before we got involved, they were just taking perimeters, like anybody within 25 miles of a store belongs to that store. And the funny part was when we used that algorithm in Boston, you had 5 stores and they were all inside of 25 miles. So it didn't help in Boston at all. But in Minnesota, there was lots of customers that were out here in Grand Forks. And what they do is get on a bus with a bar and they drive to Mall of America. Mall of America had significant customer sets in Alaska. So they come down, they party, they buy some stuff, and then they get on the bus and go home. And so, that's a good thing to analyze. Where are your customers coming from? But the preponderance of purchases came from proximity. How about that? Okay. So in year 2, we did some holdout testing. We got the results. Most of the web sales were very close to the stores. On the web they had the luxury of having many different kinds of offers, and they had created some videos on a bunch of different compelling slogans and stuff. Okay. And so what we did was we said, well, why don't we test this? Why don't we do A/B splits and figure out what drives the most sales to the store? And so we did that, and we did a lot of postcards. And what we found was that there were one or two phrases that worked way better than the rest, which is the norm. And it worked so well, I said, we're going to be able to make this work in prospecting. And we did some modeling for in the city of Houston, which we actually got a data company to let us have all their variables for just that small area. And we used their names when we pulled them, so they got some revenue back. But it actually worked quite well. It was pretty surprising that we could prospect by mail too, drive traffic by mail. And year 3, what we noticed, we do a lot of matching by hand. We don't just slap it into the machine. And what we noticed was that though the exact matches were 300%, if you'd see some that looked close but weren't exact. They were like, apartment 5 instead of apartment 4. And we noticed that the next door neighbors, that seemed to be next door neighbors, were buying, and had gotten mail. And so when we did another holdout test and used the very near neighbor, we got a 900% ROI on mail. So and then along in the process, LS Direct, Brian DeLate, who's a really nice guy, said, and very close to Lovesac, said, I think they're in Stanford or right around there, said, we ought to try this retargeting with mail, which means people who visit the website, you can look up their IP address and other things, and you can send them a piece of mail, invite them to the store, And so they did TV using the phrasing and the branding that we had verified with postcards, and they started spending a lot more on TV in those markets that have multiple stores, and whoo, it just took off. The combination of mail, well, of TV driving people to the store or driving people to the web, and then from the web sending a mail to get them back to the store, tremendously powerful. I want you to see how mail is woven into this whole thing, and modeling was going along the whole time. And so it's all connected, and in 2017, sales went up 35%. And as I said, we started with them in 2014. This is not knocked down to zero. Okay, so it took them about 20 years to get to 50 million in sales, and then they got to 100 million in the 3 years we were with them. And Eric, who worked there, said, you taught us so much. Now, let's talk about the latest case study. So now you heard about mail a little bit. Thanks for the heart. Okay, so we announced this offer, ROI, AI ROI 90 days guaranteed. It's a no-risk offer, and we got our first test in October. We started August. We got the data about mid-August. We should have got it 1st of August because the target mailing was like the 15th or something. And but so we did it in more like 60 days. But I promised 90. And so they were a big enough mailer that they had about 100,000 tests of the uniques. And it was just this fall. We got the results back on Christmas Eve. Merry Christmas. And it was a combination of catalog, postcard, and I'm not going to tell you who, because I have a rule that you can say who or what, but not who and what. And we've gotten 5 new titles in the last year or so. So it's one of those. Okay, so we promised in the contract that we would do 30%, and our uniques did 145% better response rate. This is to zero, this scale. I took the scale off because it's none of your business. But it is to zero, so their uniques generated X, and ours generated 1.45X in response. In sales per piece, ours was 147, and in gross margin, we do model on margin, it was 153%. So, pretty amazing. I mean, it's good that there's a way to know. There's detailed information by cell of theirs, by cell of ours. How many uniques were there in each cell? Where did the uniques come from? How many orders were generated by the uniques, et cetera, et cetera, et cetera. This deep dive, solid data. And let's just say we did better than the promised 30%. Why? Well, first of all, our machine learning is limited in scope. We know what we're after. I used to say to people, when data mining was the buzzword, we're all going to do data mining. After we had big data, then we had to have data mining. And of course, not the way mining works. Mining is not, oh, there's a mountain, there must be something valuable in it. No, mining is more like sluicing. We find what we're looking for, and then we dig it up and harvest it. Okay? So data mining never made any sense. It was a dumb idea. Well, AI is now the extended dumb idea. It's the automated dumb idea where there must be something. But without a labeled data set, you don't know what you're looking for. Well, we know what we're looking for, and we are scoped in on it. Okay? There's also a clear development path. I mean, we take your transactions, we take your customers, we figure it out the way we've done it. We match order after order after order, so it's transaction based. We generate about 350 variables for modeling. That's probably based on about 600 or 700 right off the bat. More important, perhaps, is that we take an actual mailing and we divide it into 2 piles, one for modeling, one for validation. And so that's the machine learning. That's the iterative process. of seeing if what the model finds as a correlation between people who bought and people who didn't buy, differentiating factor. What the model finds, we then apply to another data set to see if it actually works in both data sets. Now, working in both data sets doesn't mean it's going to work in the real world, but at least it's a check. We went up against Ripcord 2 one time, and the client was fascinated that we would have validation. And I said, well, didn't they do it? And they said, yeah, they do it, but they charge extra for it. Well, ours is built in. And the typical model takes about 20 iterations building out into the fringes. So our steps are we start with a sales and promotion label data set. Okay, we start with a mailing, right? We know the results that came back from it. We figured that out. It's like a channel view kind of attribution, where we look at the address of the orders and we look at the address of the mailing list, and we figure out who got mailed and who bought and who didn't buy. And those are our comparisons, and that's how we start. And then we have an automatic interaction detector, which is the machine learning. And the problem is, as I did an interview with a serious modeler, and he said, you know what big data means? That the p-values go way down. And what that means is that everything correlates. You can correlate anything to anything with enough data. You can correlate random number strings to pi, and now they've calculated pi out to 21 trillion characters or something. And or is it a billion? I don't know, but it's a big number and it's crazy. And in that, you'll find strings, long strings. If you generate that same number of random numbers, and there's no such thing as really a random number, but you'd find these long strings that correlate. I mean, absolutely nothing. Okay, but machines can find those strings. Humans can't find the strings. And then we got this old guy who has a white beard, and he's been around for a couple of decades doing this. And he looks at it and he says, that may not make sense, even if it does correlate, and throws a lot of stuff out, but then picks stuff that he thinks might make sense. And then we actually have an automated validation, so that even if it does make sense to him, that doesn't mean we get to use it just because he thinks it's so. That's the difference between regression and what we do. And finally, and this is the best part, we actually look at how the results measured up in comparison to the model. And we show you the connection between one and the other. So you can see if the machine was actually smart or we just got lucky. And after 25 years, it doesn't seem like luck anymore. Okay, and there's basically two schools of thought. I wanted to put this graph up because it's interesting to me. There's basically two schools of thought. One is prescriptive modeling, and that's down here. Prescriptive means we can prescribe things that might work in the future. And RFM is a great example. It's only got 3 variables, and most of the time, recency works the best. Okay? And then frequency, and then monetary. But if you want to go beyond that, you might want to bring in product. You might want to bring in some geodemographics. And then you get to regression. But the average regression, because they want to take out collinearity, collinear variables, they want to drop those out and just have the most important variable, and then the next most important, and the next most important. Whether it's linear or nonlinear. The most you get is about 10 or 12. Okay? And so that's prescriptive. It's prescribing. It gives you insights. It gives you some place to test, some place to go. Now, what's getting popular is the neural net, and they'll be 1,000 plus. And I had 2 extended conversations with the guys from Tiny Clues, really nice guys from France. And they said, but the trouble is we don't really actually, because one of their clients told me, oh yeah, we know exactly what's working. No, you don't. Not in neural net. That's not how a neural net works. A neural net is predictive. And what they mean by predictive is it will win. head to head. And the guys from Tiny Clues said to me, we have a client that does 500 models a month, and we don't examine those. We don't know why it's working. We just know that, based on the setup, and it's mostly for email, based on the setup, we know it does better than what they were doing without it, which is great. Okay? Now, here's the thing. There is a diminishing returns on the impacts. RFM is still probably the three most important variables. And as you go farther to the right, you're going to have less and less impact. So the 1001 variable isn't as powerful as the third variable, right? Just doesn't work like that way. That's not the way the world works. So, saying that there's 1,000 or 2,000 or 10,000, it doesn't really mean that the impact is that much greater. But anyway, what we do is this one. We do Chade, SPSS Chade. We have a special version of it that they wrote for us because we were pushing it harder than anyone else in the world. And it has a limit, we found out with Baseball Express finally, of 500 variables. And, that isn't much of a limit because there's lots of junk you throw in there and see what happens, and it doesn't do much of anything. And so you swap it out and put some new stuff in. You can always keep swapping out. There's always room to maneuver with 500 variables. But the point is that it's a lot more than 12, and it's not that far from infinite, okay? Because most of these don't matter anyway, and we know that. But what the benefit is that it's halfway between. It's transparent. It's transparent. It's transparent. You can see what's going on. It's transparent. So when I showed it to Dick Cabela, and I said, okay, Dick, if you had one catalog left, would you go to the blue-collar neighborhood or would you go to the high-end neighborhood? Now, this was fishing. He said, I think I'll go with the blue-collar. I said, that's what it shows. And I showed him how it showed that. He said, yep, that's what fishermen are like. I mean, his staff told me, don't you dare show it to Dick. He has like a -10 aptitude for computers. But he got it, and he liked it. And it was a great privilege that I had to work with Dick because he had a lot of common sense. Okay? So what we've done is we've combined, Matthew Schall said, you stumbled on something really great, even though we didn't evaluate every technique. And what I laugh about is that every statistician sort of wants to evaluate every technique, but it's not about the technique. If there's lumps in the soup, any technique will find them. That's what John Worth said, PhD in junk mail. My friend John. Anyway, so we have the best of both worlds. We have prescriptive, because we know which one of these matter. We know which validate. We know what keeps the guy with the beard happy. And we have enough of them that it has to be automated, and we know how to make it work, and it's a proven system. What amazes me is, we've competed against companies that mapped the moon surface and said that ought to work for customer modeling. And we've had so many different glib marketing buzzwords applied to marketing that it just amazes me that someone is willing to spend, to say, okay, we'll spend $3 million and we'll use Watson to identify our best customers to contact. Has Watson ever done it? No, but we think it's going to work. No wonder 87% fail. Let's latch on to a proven system. Let's latch on to something that's worked over and over and over and over. And let's play with the variables. Let's create new variables for your company. That's where the creativity comes, not in the technique. But it helps to have a technique where you can see what's going on. So how do we start? Well, we need a simple labeled data set. That's the facts. So if you have never been in the mail, we're going to put you in the mail. And I have companies, like one of the guys that's on here right now, I have companies that we can work with right now. So if you said, let's get started, I would say, let's put something in the mail. Let's put a couple of 100,000 pieces in the mail and see what happens. And then by the time we build all of this stuff, we might have something to show you. Okay, but we can find multi-buyers, and if you've only been doing e-commerce and email and all that, we won't have a good labeled data set, but we will have lots of data, and so we can build something for you. And by the time we get it built, we'll be ready to model, because it only takes a couple months, but we got to get in the mail. Okay, I know it's crazy, but we can do it. Okay, may be a little longer than 90 days, but from the time the results come in, we can make that happen. It'll be a lot shorter than any AI project you've ever worked on. We have clear goals. We promise 20% plus on a uniques win. Okay, if we don't do that, you walk away. And we don't charge you some big upfront cost to build it. Okay, we charge you a monthly fee that's less than the cost of a data scientist by a lot. Okay, no matter what. Well, not no matter what. If you're mailing 5 million pieces at a time, it's going to be maybe a little more. But for most people, it's not. Okay, so if we don't win by 20% on the uniques test, clear win, then you're off the hook. But at least you'll have an ROI. You'll have an actual test result, unlike every other project you've ever been spec'd. Okay, we suggest that you have at least 100,000 active customers. That's usually 0 to 12-month buyers. We use mail for maximum engagement. It takes about 3 months to set it up, so 2 months to build a database, 1 month to build a model, and we're going to do 20% better than your current methodology. We set up a 3-year contract. Why? Because our biggest disappointments have been with companies that we only had a year, and some employees don't like the fact that someone's in there. I hate to say it, but it's been sabotage, and so it takes. In the first year, you learn a lot. Everybody learns. And we get good results because we beat what you were doing. But the real money comes in the insights, in the surprises, in the inspiration, in the retests. The real money comes when we find things that we didn't expect. And that's where you grow. You get explosive growth by finding new businesses inside your business. You don't get explosive growth by tweaking it with predictive modeling. It'll never happen. Okay? So, takeaways for your CEO. Would you be interested in 20% growth? We've had that happen many times. Would you like to prove which part of your marketing is most effective? We can do that. Do that with mail. Would you like to know what offer ignites your customers? It was the core of Lovesac. Thank you for the heart. So let's get started. You can share this webinar. I'm recording it. It seems like it's working. It's also going to be on YouTube and on Periscope, already recorded, but I kept a copy for myself just in case. So we can get you this webinar over again. We can set up a 15-minute chat with your president, CEO, or CFO. I don't really want to talk to the director of marketing. That's not where we want to start. Let's start at the top. Board of directors is fine. Okay? It's also best to test in the off season. So if your big season is the fall, now is the time you want to get going. Okay, I'm really easy to spot on LinkedIn, Periscope, YouTube. You can write me in the comments below. Or write John at wdma.org. And that's it. We got done in an hour or less. Pretty good. So AI, 90 days, guaranteed. If you've got thoughts or comments on this presentation, I'd love to hear them. Because, as I said, this was just friends only, very, very small invitation list, because I wanted some feedback before, there was a day when we started in database marketing where we could put data on a PC, and I went around and told everybody I did over 100 public presentations, and what I found was that people stole my words but didn't know how to do what I did. So we're being a little more careful. And if you have a client or somebody that you think this would matter for, and they could be doing more mail, happy to talk. So John at wdma.org, be fine. There it is right on the screen there. That's an easy way to get a hold of me because I'm the president of the Wisconsin DMA. Have a great day. Like and share. Your friends will think.